Hello, in this video we're going to be talking about the inverse sine function. And so recall, for a function to have an inverse, that function must be 1 to 1. So looking at the function here that I have drawn for you, the sine function y equals sine of x, it's not going to be 1 to 1 because it's not going to pass the horizontal line test. That is, if I draw a horizontal line, it will cross more than one point on that horizontal line. But if we restrict the domain to start at negative pi over 2 and end at positive pi over 2, and I just ignore the rest of this, then our function will be 1 to 1. So our domain has to be negative pi over 2 to pi over 2 in order to take the inverse. So the inverse sine of x will be written as that sine, it'll be read as inverse sine of x, but it has that superscript negative 1. Now that's not the same in this case. It is not the same as 1 over the sine of x, which is why we also have another notation called the arc sign. And so that arc sign also indicates the inverse. So y equals arc sine of x if and only if sine of y equals x. Remember, for inverse we switched where the x and the y are, where x is between negative 1 and 1, so our outputs can only be between negative 1 and 1 for sine of y equals x. Our inputs for arc sine can only be between negative 1 and 1. And the outputs for the arc sine can only be between negative pi over 2 and positive pi over 2. So this also defines our domain and range for that function. So let's use this information and try to evaluate some stuff using the inverse sine. So I have the unit circle here. We want to find the sine, or the inverse sine, excuse me, of negative 1/2. Now we're restricted to only between pi over 2, which is right there, and negative pi over 2 down here. So we're only looking at this part of the unit circle for inverse sine. Now, the input for inverse sine is what is typically our output, and our outputs are usually y values. So on here, in that arc, I want to find a y value of negative 1/2, and there it is. So the value of this would be whatever our value is going right there, and I can't say 11 pi over 6 because that doesn't fit my domain. 11 pi over 6 is too big. It's much bigger than pi over 2. But if I went downward instead at negative pi over 6, that input would give me, for sine, would give me an output of negative 1/2. So the negative 1/2 input for my inverse sine would output that negative pi over 6. Now if I did arc sine of 0, once again I'm looking for a y value of 0, and there it is. The input that would give me that is 0 degrees or 0 radians. So arc sine of 0 is 0, or the inverse sine of 0 is 0. Okay, so that's how that's done for now. We are finished.